A charged particle is moving with a velocity v in a magnetic field B. The force on the particle will be maximum when? We know that the force acting on a charged particle Q in a magnetic field B is Q into V cross B or QVB sin theta. Here, according to the theta value, F will change. The options given, let us check. V and B are in the same direction. That means both V and B in the same direction. So theta will be 0 here. Sin 0 is 0. So the value will be, you will get F equal to 0. And in the second option, V and B are opposite direction. That is V and B are opposite, means angle is theta 180 degree and sine 180 is again 0. So force again you will get 0 because QVB into 0. Again V and B are perpendicular, means theta equal to 90 degree or sine theta equal to 1. That means force equal to QVB. And the fourth option, V and B are 45. At 45, theta equal to 45 means sine theta, sine 45 is 1 by root 2 or 0.7. So from all of these, see, sine theta value is maximum for 90 degree. So answer is option C, V and B are perpendicular. Force will be maximum when V and B are perpendicular. A particle of mass m charge q moving with velocity v describes a circular path of radius r when subjected to a uniform transverse magnetic field of induction B. The work done by the field when the particle completes one full circle is, work done is F dot D or Fd cos theta. Here it is said that magnetic field is transverse or perpendicular, that is 90 degree. Cos 90 is 0, work done is 0. Also, we can say that for a complete circle, there is no displacement. In that sense also, we can say that W work done equal to 0. So, correct option is C, 0. A charged particle moves in a uniform magnetic field. The velocity of particle at some instant make acute angle with the magnetic field, the path of the particle. We know that when a charged particle enters a magnetic field, it experiences a force equal to Q into V cross B or QVB sin theta. That means when theta varies, force also varies. So let us check for different angles what happens to the force and what happens to the path. When force varies, path also varies, shape of the path also varies. So when theta equal to 0 degree or 180 degree, sin theta, sin 0 is 0, so force will become 0. That means it won't, the charge particle goes in a straight line path. It will not get affected by the magnetic field because no force is there. Next, when theta equal to 90 degree, what happens? That is, it enters at an angle 90 degree. Then goes in a circular path and comes back. So the path will be circular. Here it enters, then it exists, come back. So angle of deviation is 180 degree in this case. So when it enters at right angles to the magnetic field, the path will be circular and the deviation is 180 degree. Now comes our question. When it is less than 90 degree, that is acute. Acute means less than 90 degree. It may be 45 or any other degree. So when it enters the magnetic field at an acute angle, it goes in a helical path. So correct option is option C. Due to 10 ampere of current flowing in a circular loop of 10 centimeter radius, the magnetic field produced at its center is 3.14 into 10 raised to minus 3. The number of turns of coil is magnetic field due to a circular coil is mu 0 I divided by 2R. If there are n number of turns, then mu 0 I n in divided by 2R. Magnetic field is given as 3.14 into 10 raised to minus 3 is equal to mu 0 is 45 into 10 raised to minus 7 into I is given as 10 ampere into n divided by 2 into R is 10 centimeter, 10 into 10 raised to minus 2 meter. And from this we can find out n. So if you calculate n, you will get number of turns as 50. So correct answer is option C. A beam of ions with velocity 2 into 10 raised to 5 meter per second enters normally into a uniform magnetic field of 4 into 10 raised to minus 2 Tesla. If the specific charge of the ion is 5 into 10 raised to 7 coulomb per kilogram, then the radius of the circular path. When a charged particle enters the magnetic field normally, that means theta 90 degree, the force experienced by the charged particle, here it is ions. So it is F equal to Q into V cross B or QVB sine theta. Here theta is 90 or sine theta is 1. So it is QVB. And when it enters 90 degree, path will be circular. So the force is centripetal force. In circular path, force experienced is centripetal, and centripetal force equation is mv square by r. From this we can cancel v and r becomes mv divided by qb, or we can write it as v divided by q by m into b. Just to rearrange this equation like this. Why? Because in the question it is given that specific charge. Specific charge means charge to mass ratio q by m, that is given as 5 into 10 raised to 7. So now we can find out r, that is v. V is 2 into 10 raised to 5 divided by q by m is 5 into 10 raised to 7 into B is given as magnetic field 4 into 10 raised to minus 2. So when you calculate this one, you will get 0.1, and the correct option is option A, 0.1 meter. A 1 meter long conducting wire is lying at right angles to the magnetic field. A force of 1 kilogram weight is acting on it in a magnetic field of 0.98 Tesla. The current flowing through it will be. We have to find out the current, and the wire is in the magnetic field, conductor in the magnetic field. So, force acting on a conductor in a magnetic field is BIL sine theta. Here it is right angle to the magnetic field, that means theta equal to 90 degree or sine theta equal to 1. So we can write F equal to BIL, and it is given that a force of 1 kilogram weight is acting on it. So the equation for force is mg. We can write mg equal to BIL, and m is given as 1 kilogram. We know that g is 9.8 and b is given as 0.98. I we should find out, and L is 1 meter. From this we can find out I. We will take other terms to the left hand side. So it is 9.8 divided by 0.98. I is equal to this. That is how we can do this, multiply it by 100. both numerator and denominator. So we will get 980 divided by 98, that is 10. So answer is option B, 10 ampere. An alpha particle and a proton travel with the same velocity in a magnetic field perpendicular to the direction of their velocities. Find the ratio of radii of their circular path. We have to find out the ratio of radii of alpha particle and proton. Usually we write proton as H11 and alpha particle as He24, helium atom. So this represent charge and these two represent mass. Here for proton plus one charge is there, for alpha particle plus two charges are there. So let us find the ratio. We already know that equation for radius of a radius of path of a particle when enters in a magnetic field perpendicular to it is R is equal to mv divided by qb. Here it is said that they are entering with the same velocity. So when we take the ratios, this velocity part will go and they are entering in the same magnetic field. So when we take the ratio of radius, these two will go. And it depends on mass and charge as m by q. So radius of alpha particle we can write mass of alpha particle divided by q of alpha divided by radius of proton as mass of proton divided by charge of proton. We can rearrange this equation, that is we can cross multiply this, then we will get m alpha divided by q alpha. When it goes to numerator, this will get reverse. So q of proton divided by mass of proton. Mass of alpha is 4 times mass of proton divided by q of alpha. Q of alpha, charge of alpha is 2 times that of proton into charge of proton is there, mass of proton. Then when we calculate this, we will get as 2. So correct option is option C, 2 is to 1, 2 by 1, 2 is to 1. A part of a long wire carrying a current I is bent into a circle of radius R as shown in figure. The net magnetic field at the center of the circular loop is magnetic field due to the loop is equal to mu 0 I by 2R and magnetic field due to conductor is mu 0 I by 2 pi R. So net magnetic field is mu 0 I divided by 2R plus mu 0 I by 2 pi R or mu 0 I by 2R into 1 plus, here it is 1 and 1 plus 1 by pi, or we can write mu 0 I divided by 2R into, here we can take the LCM, so pi plus 1 divided by pi, or we can write mu 0 I by 2 pi R into pi plus 1. Option C is the correct one. In the figure, what is the magnetic field at the point O? In the figure, there are 3 parts, 1, 2, 3. So due to the first part, magnetic field equal to 0 because the point O is on the axial line of the conductor. And due to the second part, that is it is only half portion of the circle. So if it is a full loop, then magnetic field will be mu 0 I divided by 2R. here only half portion is there, so half into mu 0 I by 2r, or mu 0 I divided by 4r. And due to the third portion, B3 is equal to mu 0 I divided by 4 pi r, because only half the portion of the conductor is there, only half part is there. So if there is a full conductor, then we can write mu 0 I by 2 pi r. So only half portion is there, we will take the half, so it is mu 0 I by 4 pi r. And when we add all these three, we will get mu 0 I by 2 4r plus mu 0 I by 4 pi r. Option C is the correct one.